It's one of the most profound questions ever asked. How common is life in the universe? To answer that, we first need to find water, especially water in its frozen form. Because on Earth, wherever we find water, we find life. Now, for the first time, astronomers have found direct evidence of frozen water drifting through the dusty outskirts of a young, sun-like star system. Not in our own solar backyard, but 155 light-years away. On May 15, 2025, the journal Nature published a groundbreaking study detailing how NASA's James Webb Space Telescope, the most powerful observatory humanity has ever launched, has detected fine particles of water ice in the debris disk of HD 1813227, a star located in the southern constellation Telescopium. The research was led by a team including Chen, an astrophysicist at Johns Hopkins University in Maryland. HD 1813227 may not be a household name, but this cosmic newborn, just 23 million years old, is stirring up headlines across the astronomy world. That's because its disk of dust and debris holds striking similarities to the early Kuiper belt in our own solar system. And within that ring, Webb has revealed a cold, sparkling fingerprint, the unmistakable spectral signature of water ice. This discovery didn't come easy. To even spot these tiny icy grains from across 155 light-years, the James Webb Space Telescope had to peer into the outer reaches of the disk, a region far enough from the star that temperatures remain frigid, allowing the ice to survive without sublimating into vapor. This region, scientists believe, is where comets and icy planetesimals are born. And it's from regions like this that Earth may have once received its water. But here's where the story gets even more exciting. These aren't just isolated ice particles. They're part of a dynamic churning system where icy bodies frequently collide, grind down, and launch plumes of dust into space. These dusty shards are just the right size for Webb's mid-infrared instrument, MIRI, to detect. And it did so with exquisite precision. HD 1813227 is a very active system, said Chen in NASA's press release. Frequent collisions between icy bodies in this disk are constantly stirring up fine particles of dusty water ice, which are perfectly sized for Webb to detect. It's like watching a young planetary system throw snowballs, cosmic snowballs, in slow motion. But let's talk for a moment about what that really means. Water ice in space isn't like a clean sheet of frost on your car windshield. It's mixed with silicates, carbon compounds, and organic materials, the same ingredients that later form comets, moons, and even life itself. These dirty snowballs are believed to have played a major role in delivering water to Earth, and may do the same for young rocky planets forming around HD 1813227. The implications are enormous. This detection marks one of the first clear, direct confirmations of water ice in the planet-forming zones of another star system. And because HD 1813227 is so young, we're essentially looking back in time, witnessing what our solar system might have looked like over 4.5 billion years ago, when the Earth was still a molten rock awaiting the delivery of its life-sustaining water. Scientists believe that water on Earth likely arrived via impacts from icy comets or asteroids originating in our solar system's own version of a debris disk, the Kuiper belt. In HD 1813227, we may be seeing the same process unfolding, the birth of rocky worlds seeded with ice-rich building blocks that could eventually form oceans. Webb's observations show that the outer regions of the disk are rich in water ice, but closer to the star, the picture changes. Ice is far less abundant. Why? There are two possibilities. Either the ice has been vaporized by ultraviolet radiation from the star, or it has already been incorporated into larger rocky bodies called planetesimals, embryonic planets in the making. These planetesimals are too large and cool to be detected directly by Webb's infrared sensors, effectively hiding their icy cargo from view. This creates a tantalizing mystery. Are we seeing the delivery trucks of life's most essential ingredient? Or are we catching a glimpse of frozen oceans locked inside future planets? And here's something even more intriguing. The disk of HD 1181327 isn't a uniform, peaceful ring. It's a turbulent environment. Debris disks like these are the chaotic aftermath of cosmic construction sites, where gravity, collision, and chemistry are continuously shaping and reshaping the system. The research team believes this star system could be in the very early stages of forming planets. And HD 1181327's age lines up with what we understand about our own solar system's development. It's in the same chaotic, high-energy phase that shaped Earth, Mars, and Venus, when collisions were constant and the ingredients for habitability were being stirred together. And the similarity doesn't stop at timing. The structure of HD 1181327's debris disk closely resembles what scientists believe the Kuiper Belt used to look like. It's a donut-shaped ring teeming with icy bodies and potential comets. In our own solar system, this region gave rise to Pluto, Haumea, and countless icy visitors that streak through the night sky. Now we're seeing a version of that 155 light-years away, but still governed by the same physical laws, the same cosmic recipe. This is how planetary systems are born. This is how water, the molecule that makes Earth a blue oasis, may spread across the galaxy. And it raises the deeper possibility that Earth's story may not be unique. Astronomers have suspected for decades that water is a cosmic constant, formed in molecular clouds, frozen into comets, and scattered like seeds by solar systems in formation. But now, with Webb, we're no longer just inferring its presence. We're directly observing it, glinting across the cold void of space. And that presence matters because water is more than just a molecule. It's the medium through which life emerges. It dissolves chemicals, transports nutrients, and serves as a thermoregulator, all critical conditions for biology to take root. So this detection of water ice isn't merely symbolic, it's foundational. It suggests that conditions for life, or at least the ingredients for life, might be far more widespread than we ever dared hope. And let's not forget, this discovery was only possible because of the unprecedented sensitivity of JWST. Unlike previous telescopes, JWST's instruments aren't hindered by Earth's atmosphere or limited by narrow fields of view. Its mirror is over 21 feet wide, and its mid-infrared spectrograph is so sensitive that it can detect temperature differences of just a few degrees Kelvin across vast interstellar distances. Webb's mid-infrared instrument can detect wavelengths of light that pass straight through dust, revealing the icy footprints that other telescopes would completely miss. It's like switching from an old black-and-white TV to a crystal-clear 4K screen, but for space. The level of clarity Webb offers means we're not just guessing anymore, we're observing, in real time, the processes that may have seeded life on Earth and may now be setting the stage for life elsewhere. So the real question becomes, is HD 1181327 just one of many? Are there thousands or even millions of young planetary systems with icy disks silently preparing to form ocean worlds? Webb's findings suggest that frozen water may be far more common than we ever imagined. And that has huge implications for the search for extraterrestrial life. Every time we discover water beyond Earth, we're expanding the potential habitats where life could one day exist, or may already be thriving. From the icy moons of our solar system to the debris disks around distant stars, the universe keeps whispering the same message. Water is everywhere. And yet, we've only just begun to listen. The James Webb Space Telescope is rewriting what we know about the building blocks of life. With every new observation, it's revealing how planetary systems form, evolve, and, possibly, how they become habitable. So keep your eyes on HD 11813227. One day we may learn that it's not just a dusty nursery for rocks and ice, but the cradle of a future alien ocean. And beyond that horizon, a deeper question lingers. In all this frozen silence, who or what is waiting to awaken? End hook. Call to action. If discoveries like this ignite your curiosity, don't just scroll past. Subscribe, because every week the universe speaks in photons, and we're here to translate them into wonder.